Alright, welcome back to the Math 140 instructional video series. And here we're going to look at linear equations again, continue on from the last video, called it Linear Equations 2 here. So first, let's remind ourselves where we were at. I think that we could sum things up with a couple examples of forms of an equation. Let's say y equal to m times x plus b, and again this is a relationship between x and y. And maybe over here we're going to write an example. Okay, so for instance, y equal to 2x plus 3. Okay? And I think that here we know that this is this m value, this is the slope, and that is the change in y over the change in x, and that stays constant when we have a linear relationship. And here, this 3 here, we call this the y-intercept, and this is called the slope-intercept form line. And we could do a quick sketch. We know it goes through at 3, and it's a little steeper. It's got a slope of 2, something like that. Remember, recall that's saying, okay, if I go up 2 and to the right 1, I'll be back on the line. All right. And then we have the point slope form. Okay, and this looks like y minus y1 is equal to the slope times x minus x1. All right. And here we have, okay, another form of that is y equals m times x minus x1 plus y1, where we note that this line goes through the point x1, y1, and slope of m. All right, so now over here in our example, let's see if we can put this first equation into its a point slope form. And one way to do that is we know, change up here, we know that the slope is 2, right here, yes. And, well, what point does it go through? It goes to the point, well, let's see. What we do if I plug in 1 for x, right? That means that I'd get y equals 2 times 1 plus 3, and that is 5. So it goes through the point 1, 5. And so a point slope form would be y minus 5 equal to 2 times x minus 1. Okay. Or y equals 2 times x minus 1 plus 5. Okay, and we could check, would that be the same in the slope-intercept form? See, 2x minus 2 plus 5 gives us y equals 2x plus 3 if we were to solve that. Okay, so that's the point slope. And lastly, we have the standard form, probably the least used. Standard form. And that looks like ax plus by is equal to a constant c. All right. So our standard form of this line, let's see, we got negative 2. If I subtract 2x from both sides, I get negative 2x plus y equals positive 3. And that would be that version. All right. Those are our 3 standard forms. And again, I guess I should say importantly, the slope is m equal the change in y over the change in x is equal to y2 minus y1 over x2 minus x1. Remember, what are the units here? With units of y over units of x. All right? That's going to be important. Those units are useful for the applied problems. All right. So let's look at a couple examples. Last video we did an example of where we did 2 points and found the slope-intercept form, and now we wanted the equation of a line in slope-intercept form that goes through the point 4, 0 and has slope negative 1/2. And then we want to graph that line. All right? So, let's see here. First of all, we get it. Always sketching a picture is always a nice idea if you're unsure. And here the sketch would be, notice 4, 0. That's x is 4 when y is 0. So right here, 4. We know we go through this point here. All right. And let's see, if we recall, it's a negative slope. So I could go down 1 and to the right 2. And that would put me at the point 6, all right, because I went right 2, and negative 1. And so the sketch of this looks something like that. All right. And now we want to, that's what I call the geometric viewpoint of that line. And what we want to do is look at the algebraic. They both have their advantages, but we need to be able to go back and forth. So here, well, we want to do, let's see. We could use, notice that 4, 0 is the x-intercept, not the y-intercept. All right, so it doesn't just plug right in. We have to be a little careful there. I'd say using the point slope form is a nice way to do this. We get y minus 0, so that's nice, times the slope, which is negative 1/2, times x minus 4. All right, so that gives us in slope-intercept form y equal to negative 1/2 x. And we are distributing this negative 1/2, right? So we have negative 1/2 times x, and then negative 1/2 times negative 4. Alright, got to be careful with those negatives. And that's going to give us a positive 2. Let's see, I know it's only a sketch, but we look over here, positive 2. If we saw negative 2, we'd be skeptical of our algebra over here. But here we are in the slope-intercept form. Let's see what the line looks like. Let's go to Desmos real quick. And here, this line that we see is y equals negative 1/2 times x minus 4. Okay, and that's about what we graphed it as. And let's see, we see that the y-intercept is 2, like the slope-intercept form of the line told us. And here's the x-intercept. Here is the x-intercept at 4, 0. All right, good. Good. Now, let's look at another example. Now we consider the linear equation 2x plus 3y equal to 6. Identify a slope along the horizontal and vertical intercepts, and then graph the line. Okay, so let's see. Well, one way to find the slope is put it in slope-intercept form and see. In order to do that, what we're going to do is we start with 2x plus 3y equal to 6. All right, and that gives us, we're going to subtract 2x from both sides. 3y equals negative 2x plus 6. And then we're going to multiply both sides by 1/3, or divide both sides by 3. Don't forget the whole side over here. I think it's worthwhile to write the parentheses, as that's definitely what we mean. And so we get y equal to, let's see, negative 2/3 x plus 1/3 times 6 is 2. Okay. And so we see that we identify the slope is negative 2/3. All right. And now the horizontal and vertical intercepts. All right. I think the easiest way is start with the equation 2x plus 3y equal to 6 in standard form. Well, really, I guess since we put it in y-intercept form, the vertical intercept, this tells us b equals 2, so vert intercept is when x is 0 and y is 2. Notice that's what we get there. Now the x-intercept, or the horizontal axis intercept, I would use the standard form, and what it was that we saw, that's we want to know the x value when y is 0. Okay, so what I would do is plug 0 in for y. I get 2x equal to 6, and x is equal to, I multiply both sides by 1/2 to get x equals 3. Okay, and that gives us our horizontal or x-intercept. Okay. Now let's take a look at what this thing. Now I graphed it in Desmos. Let's double check what we have here. Let's see here. This slope, it's going downhill left to right, and we said the slope was negative 2/3. That makes sense to us, and we could even be more specific and look. If we go down 2 and to the right 3, we wind up back on the line. So that's good. And let's check our x and y intercepts. Let's see here. We got 0, 2 for our y-intercept or vertical intercept, and 3, 0 for our x-intercept or horizontal. Good. All right. Hopefully this is shaking some memories. Next up, I think we've got one more example. Before we get the next example, we're going to look at parallel and perpendicular lines. Two lines are parallel if, well, hopefully we remember this, they're parallel if they have the same slope and technically and a different y-intercept, otherwise they're the same line. If they have the same slope, same y-intercept, they're the same line. All right, that makes sense to us. Let's maybe just draw a quick picture. Two parallel lines. Okay, let's say slope of 1, positive 1. That would be one line, something parallel to that. It'd have to be, do my best with my picture, but something like that. All right, and that's our picture, and the slopes are the same. Now, two lines are perpendicular if their slopes are negative reciprocals of one another. What this means is the slope of the perpendicular line is equal to 1 over m. Negative, apologize. The slope of the perpendicular line is equal to negative 1 over m. Another way to think about that is the slope of the perpendicular line times the slope of the original line. They're perpendicular. That means that they equal negative 1 when we multiply those two things together. Okay, so that's another way to think about it. So let's see, does that make sense to us? Maybe a quick picture to see. Let's see. Okay, again, all right, there's the line y equal x. Okay, so according to this, something perpendicular would have a slope of negative 1. So let's say y equal to negative x. Let's what that looks like. We'll do that one in green. Oh, and at least roughly they look perpendicular, meaning this is a right angle. All right, so let's practice using that. Let's consider a line determined by 4x plus 2y equal to 8. Okay, so let's take a look at that in the smaller Desmos window. 4x plus 2y equal to 8. Okay, now, so it has a negative slope. And so let's see what we find out here. Well, the slope of the original line, we'll call this M. The slope of this line we'll call M. Now we could find that by subtracting 4x from both sides and then multiplying both sides by 1/2. So that's going to be negative 2x. And let's see, looking at our picture over in the lower left corner, it's certainly negative, and it's about down 2 and over 1 to the right 1, and that matches up what we're getting algebraically up here. So that means that the slope of the parallel line L has a slope, oops, I apologize, I wrote something wrong. The slope is negative 2, not negative 2x. The slope is a constant. That's a good catch there. Slope is negative 2. He's writing red to punish myself for when I make a mistake. Okay, so now let's see, through the point. So think about what you want to do. I would try this on your own right now before I do it. Now, what I would do is say, let's say y equal, I would use the point slope form. So y minus 1 equals our slope, which is negative 2 times x minus negative 2, which we may want to rewrite as y equal to negative 2 times x plus 2, right? Negative times a negative is positive. Plus 1, because I added that 1 to both sides. And if you want to see it in, particularly in slope-intercept form, we could distribute the negative 2, we get negative 2x. And then negative 2 times positive 2 is negative 4 plus 1 minus 3. Okay, good. Next up, let's say we have perpendicular. That's a little trickier. So now we have 4x is 2y equal 8. Same line, perpendicular. Well, we saw that the slope of this line was equal to negative 2. All right? So something perpendicular now, this new slope of line L, slope of L, the line perpendicular to it, is going to be positive 1/2. When I multiply those two together, I get negative 1, which is we talked about. All right, and again, I'd use the slope-intercept form. Point slope form. Get y minus negative 2 equals 1/2 times x minus 1. A little tidier, this is y plus 2 equal to 1/2 times x minus 1. And that's an equation of a line. We could leave that there. In fact, maybe let's go look at this small window again here, Desmos, and double check and put in that line that we just got. Let's see here. So y plus 2 equals 1/2 times x minus 1. Oh, and sure enough, they look pretty perpendicular to me. And there we are. Okay, we'll be moving on from these types of linear equations. Hopefully we got a handle on that. I would try a few homework problems, and please let me know if you have any questions. Have a great day.